What if one of humanity's absolute greatest achievements never actually happened? Picture it, July 1969. The entire world watched in breathless anticipation as we prepared to step foot onto another world. But today, well, a shadow of doubt lingers. Millions of people still debate whether the Apollo 11 mission was the pinnacle of human exploration or just a massive, elaborate hoax. Today, we're going to look at the facts, the physics, and the photographs to uncover the real truth.
It's a seriously thought-provoking mystery, right? I mean, could that iconic footage have been filmed on a Hollywood soundstage? Or maybe in the remote deserts of Nevada? We're gonna dive deep into these claims and separate fact from fiction. Let's kick things off with Section 1, the historic mission. So to understand the landing, we have to understand the intense pressure cooker of the Cold War space race, which was really ignited by the Soviet launch of Sputnik back in 1957. In May 1961, President John F. Kennedy issued a bold, seemingly impossible challenge to land a man on the moon and return him safely to Earth before the decade was out. And NASA delivered. On July 16, 1969, a massive Saturn V rocket launched astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins into space. 4 days later, the lunar module Eagle actually touched down in the Sea of Tranquility. Armstrong and Aldrin walked on the surface, planted the flag, collected lunar samples, and then safely splashed down in the Pacific Ocean on July 24th.
Which brings us to Section 2, the Great Lunar Conspiracy. Now, despite the global broadcast and the safe return of the crew, skeptics soon started questioning the authenticity of that NASA footage. And to be fair, the accusations are pretty specific and definitely intriguing. Think about it. How could an American flag wave in the airless vacuum of space? Why are there literally no stars visible in the lunar sky? Why do the shadows look like they were cast by artificial studio lights? How on earth did the astronauts survive the deadly radiation of deep space? And how could those iconic footprints be perfectly preserved in completely dry dust? These are fascinating claims, and they demand objective, scientific answers. So, let's get into those answers in Section 3, Photographic Oddities Explained. Let's start with the famous waving flag. The claim is that it fluttered, which would prove there was wind, and therefore it was shot on an Earthbound film set. But what's the actual fact here? Well, the flag was suspended by an inverted L-shaped rod specifically so it wouldn't just hang limply in the zero-atmosphere environment. When they were planting it, the astronauts had to physically twist the pole back and forth to dig it into the tough lunar soil. Because there's no air drag and a vacuum to slow things down, that rotational momentum caused the free corner of the flag to swing back and forth, almost like a pendulum. Combine that momentum with permanent wrinkles from days of being packed away tightly, and still photographs simply give the illusion of rippling wind. Next up, the mystery of the missing stars. This really comes down to basic photography 101. You see, the sky on the moon is black not because it's night, but because there's absolutely no atmosphere to scatter the sunlight. The lunar surface during these spacewalks was brightly illuminated by the sun. We're talking just as bright as midday on Earth. So to capture the brightly lit astronauts and that glaring white terrain without totally washing out the image, the Hasselblad cameras mounted on the astronauts' chests needed a very fast shutter speed of 1/250th of a second. This fast daylight exposure simply didn't allow enough light into the lens to capture those incredibly dim background stars. Okay, then there are the shadows. Theorists often claim that converging shadows imply multiple studio spotlights. But the lighting on the moon is this extreme high-contrast environment of alternating bright light and dark shadow. It's an effect painters call chiaroscuro. Without an atmosphere to scatter the light uniformly, sunlight bounces off multiple reflective sources. You've got light coming from the Earth, reflecting off the shiny lunar module, and even bouncing off the jagged lunar dust itself. When all these shadows fall onto uneven, rolling craters and hills, and then are captured through wide-angle lenses, they naturally distort. They display the properties of vanishing point perspective, which causes them to visually converge. No studio lights required. Let's move on to Section 4, Surviving the Space Environment. Moving past the camera anomalies, we have to investigate a very serious biological question. How in the world did the crew survive the deadly radiation of the Van Allen belts? Those are zones of geomagnetically trapped electrons and protons that surround the Earth. Well, NASA scientists were fully aware of this threat. Their solution was twofold. First, they intentionally plotted a path to quickly bypass the most dangerous, dense inner proton zones of the belts. And second, they traveled at incredible speeds, zipping through the inner belt in about a minute and the outer belt in about an hour and a half. So the crucial point here is the actual radiation dose the astronauts received. Thanks to that fast transit time and the thick, protective aluminum hulls of the spacecraft, the Apollo 11 crew absorbed an exceptionally low average skin dose of just 0.18 rads. To put that into perspective, that's roughly equivalent to the ambient background radiation you'd receive just living at sea level on Earth for about 3 years. The radiation was simply not the immediate death sentence that skeptics claim it to be.
There's another huge environmental mystery, those pristine footprints. On Earth, if you step in perfectly dry sand, it just immediately crumbles, right? You need moisture to hold a perfect footprint. So how did Buzz Aldrin leave such a crisp print in the totally dry lunar vacuum? The secret actually lies in the dust itself. Lunar dust is not weathered or smoothed out by wind and water like sand is here on Earth. If you look at it under a microscope, lunar soil is incredibly jagged with very sharp edges. When a heavy astronaut boot steps on it, these sharp edges literally mechanically lock together in the vacuum. It acts exactly like wet sand does here on Earth, holding its shape perfectly.
Now, let's look at Section 5, Absolute Proof.
Because honestly, the physical proof is overwhelming. The Apollo 11 crew brought back 47.5 pounds of actual lunar rock, which is geological material fundamentally different from anything found on Earth. In video footage of the lunar rovers from later missions, you can see the dust kicked up by the wheels, settling back to the ground in perfect, uninterrupted parabolic arcs. That is literally only physically possible in a vacuum where there is zero air resistance to form lingering dust clouds. We also have Apollo 15's famous hammer and feather drop, proving vacuum physics right before our eyes. And today, modern technology has only strengthened this case. The Lunar Reconnaissance Orbiter has captured stunning, high-resolution images of the Apollo landing sites, showing the footprints and equipment still sitting exactly where they were left decades ago.
Which brings us to our final section, Section 6, the verdict. When we synthesize the historical record, the photographs, and the absolute physics of a vacuum, a very clear picture emerges. The facts overwhelmingly support NASA. Now, the conspiracy theories are undeniably fascinating, for sure, and they tap into a completely natural human curiosity to question the impossible. But objective science prevails. The moon landing remains one of humanity's absolute greatest technological achievements. More than 50 years later, it continues to inspire new generations to explore the unknown and really push the limits of human possibility. If you enjoyed this documentary explainer, subscribe to Chronexa for more fascinating stories about history, technology, science, mysteries, and the future. We conquered the moon over 50 years ago. The only question left is, where will we go next?